viewers to another episode on ASUSG 12 exams. So this is basically the last episode in this series where I'll focus on the November 2022 Science Paper 1. So if you haven't seen the other episode, please check out on our YouTube channel. So let us straight move to question C3. Question A, define radioactivity. So let us just create space so that we should be able to define what radioactivity is. So radioactivity basically refers to a spontaneous process in which atoms break down into stable particles and release energy. So what is key here is, one, it is a spontaneous process. Number two, atoms break down into stable particles and release energy. So key, spontaneous process. Number two, breaks down of atoms into stable particles. That process is what is known as radioactivity. Question B, London nuclide decays to form polonium by emission of alpha particle. Write the decay equation. So we have this London nuclide. So we are emitting the alpha particle, which is helium. So this is B. We have this London 222, then 86. So it decays to release the helium, then plus energy. So now what is going to happen is, because it has released this helium, we need to subtract the mass number here of this helium, then also subtract the proton number of helium. So it will be 222 minus this form. We are going to get polonium to be 218, then 84. So that when I had this one plus that one, I should get 86. Then this one plus this one, I should get 222. So this is the symbol of polonium is Pa. So here it's Pa. So once you do that, you are good to go. Question C, figure 3.1 shows the results obtained to determine the half-life of the radioactive element. So we have the activity in counts per minute, then we have time in minutes. Roman numeral 1, plot a graph of activity against time for the element. So the activity is the first one, so this is the y-axis, then this is the x-axis. Then Roman numeral 2, determine from the graph the half-life of the element. Then Roman numeral 3, state one possible source of background radiation. So what is key now is for us to ensure that when we are graphing this graph, it is well scaled. So how do we ensure that? Ensure that the interval of the graph that we are going to plot remain consistent. So you look at the maximum. The maximum here is 42. The minimum is 5. So what we can do is we can start from 0 to 45. Then we can be increasing in the interval 5, 10, so that 5, 5 like that. Then here 0 to 3.5. This one we can increase by the interval. The interval is consistent, is 0.5. It's in the interval of 0.5 like that. So what is crucial is ensuring that these increase in the same interval. So we've established that we'll be jumping by 5. So 5 to 10 like that. Then once you determine that, we can go to the graph paper and plot this information. Okay, so now we have the graph paper well labeled. Like I had indicated, you need to ensure that the intervals are consistent. So you notice that these intervals are 5. Then this is 0.5. So because of that, the graph will be well scaled. And ensure that you label your graph correctly. You notice that we have time here labeled correctly, which is the x value. Then we have also the activity well labeled, which is the y value. So once you do that, you can start plotting. So let us start with the first one. We have 0,42. So at the beginning we had 42 accounts per minute. So along 0 axis, I'll go and look for 42. Remember, these are 10 intervals, so meaning 10 subunits, so meaning each subunit is a 5 divided by 10, which is a 0.5. So a 42 should be a 4 subunits above 4, so it should be basically here. This will be 42. Let me use a red color so that you should be able to see clearly. Then we come to 0.5, 34. So you go to 30, then again 4 units above, but it will be 0.5, so it will be somewhere here. Then we have 1,24. So 1,24, which is just below 25, which should be somewhere here. Then we have 1.5, 18.5. So 18.5 is just this is 19, then we have 18 here, so 18.5 is somewhere here, like here. Then we have 2,14. So 2,14 is just 2 subunits below 15, which is here. Then we have 2.5,9. So 2.5,9, which is just 2 subunits below 10, like that. Then we have 3,7.5. So 3,7.5 is just the halfway between 10 and 5, which is somewhere here. Then we have 3.5,5, which is somewhere exactly here. So once you have these points, it's just to use your pencil and make a smooth graph that will pass through the middle of these points to make a graph. So you have something like this. Then once you do that, you are good to get these 4 marks. So key, label your graph properly and show these dotted points. Then once you do that, we can go to Roman numeral 2. Determine from the graph the half-life of the element. So from the graph, we are starting with 42. So what time would it take for the activity to reduce to half of 42? So half of 42 is basically 42 divided by 2, which is 21. So at 21 counts per minute, what time has elapsed? So 21 is here, then you come and join this point. So once you come here and join this point, then you need to come and read down here. So you lead down that. So what's the leading there? That's what we need to do. Now you notice that the increment here is 0.5. So there are 10 subunits here. So to find the measure of one subunit is 10 divided by that, which is 0.05. So if you come and count here, I'll use the black one. So from here, this is 1, 2, 3, 4, 5, 6. So it's about 6. So it will be 0.05 multiplied by 6, which we are going to get 0.3. So this gives me 1.3. So when you come here, it will be 1.3 minutes. So 1.3 minutes. That's the half-life. So make sure that this shows it clearly on your graph, and you come and give that. Once you do that, you are good. Then Roman numeral 3, state one possible source of background radiation. So what are the possible sources of background radiation? So basically there are 2 sources of radiation. So these are from radioactive substances. So 1, radioactive substances such as potassium, which is potassium 14. Then we also have carbon 14. Then we also have radium. These contain radioactivity elements. Number 2 is cosmic rays. So These are the rays that are coming from the sun. So you are going to have things like the ultraviolet, visible light. All these contain some kind of radiation. So these are the two key sources. So once you do that, you are good to go. So basically this is how you answer question C3 to get the 10 marks. So thank you for joining me in this episode. If you haven't seen the last 15 episodes that are covered part of the entire paper, please check on our YouTube channel. Thank you viewers for watching this episode. If you find this video to be helpful, please consider liking, and also if you're new to this channel, consider subscribing. By liking, subscribing and sharing, you are going to help us improve our visibility. A simple like from you makes a big difference. So once you subscribe to our channel and go to our channel, you discover that we've got so much content. So we've got mathematics based revision questions, we've got physics, we've got chemistry, then we've got also topic based section for all the subjects. And this is the best section for you if you're having any challenges in any particular topic.